Let's wrap up reflection with one example. So given the graph of y equals to fx, you want to sketch the graphs of y equals to f of negative x and y equals to negative fx. Okay? So when we think about these two transformations side by side, I think for us it's very obvious that here, like I just apply a negative one outside. This is a reflection in the x-axis. Okay? Whereas this f of negative x is one area where many students usually get confused because we are reflecting about the y-axis. So every time I see these two side by side, or anytime I see a negative x actually, and I know I'm doing a reflection, what I will do is I will visualize the Cartesian plane. Okay, and what I do is I think about this like fx, right? And since I need to do like f of negative x, I think of it as now my negative x appears over here. Okay, so that indicates to me that it is the y-axis that is going to be the axis of reflection. Okay, now this one is just my own visualization. I just hope it helps you, but I don't want you to sketch this, okay, because not very accurate. So this is how we know that f of negative x refers to the reflection in the y-axis. Okay, so moving on to the solution itself, my tip for you is that since we are given several points over here, what we can do is to transform the point by point and then we sketch out the graph from there. Okay, so for each of the x coordinates now, I'm going to multiply by negative 1. So my a will now transform to 3, 0. B will transform to positive 3 over 2. C will transform to 0. Well, actually no change, right? Because you multiply by negative 1 is still 0. And then for D, I will get negative 1. Okay, once you have plotted out the points over here, then it's easier to connect them with the graph. All right. Then, of course, label your graph. Now, for the next one, the solution has already been printed for you. Okay, so I think it's quite clear that we do the reflection about the x-axis, so our graph will look something like that. Okay, yeah, so nothing much to pay attention to over here. I just drew it again so that it's a bit clearer on your notes if you need to um, sharpen any blurry images. Okay. So we're at the end of this like first chunk that deals with translation, scaling, and reflection. I've just copied out a snippet of what has been printed inside your notes. I would like you to just pay attention to the consistency in the replacements. Okay, and um, in fact, actually, many of you may be wondering, like, teacher, how come you keep talking about like replacing like your y with the y plus a when it's easier for me to work with this? The reason why I've been doing this is because of the consistency with the replacements. Let me explain a little bit more. Notice that when we replace x with x plus a, I do a translation in the negative x direction, right? So if I can apply that same logic here, replace y with y plus a, you find that it's also a translation, but in the negative y direction. The fact that this moves in the same manner um, is very comforting for me because then I know that I can always rely on this idea that there's a bit of that opposite effects happening between the algebraic replacements as well as the geometrical transformation. Okay, looking at your replacement of x with ax, also we have a scale factor of 1 over a, right? So there's that opposite kind of effect that is going on. So like anchoring on this algebraic procedure is actually quite helpful for us because we've got so many transformations to handle. All right, so we are looking for some consistency to help us relate the, the geometrical transformations accurately. So this is why I have this note over here that they go in opposite directions. Okay. And one last thing that I would like you to take note from this whole set of transformations is that when we do this kind of replacement, that replacement is not just on the equation of the graph. This replacement can also apply to the equation of the asymptotes. Okay, we have seen that in the earlier example. So this is a really useful tip for you because many students tend to get very confused when it comes to adjusting the asymptotes. They don't know what to do. And then we always point them back here. Actually, whatever you have been doing to transform the equation can be done similarly for the equation of the asymptotes.